Hello, this is Eric Zilke, and this is my progress report on datum target optimization. The status I'll be going over today are beam deflection equations, assumptions for beam equations, code layout and optimization criteria, and current progress and forward work I have still yet to do. The first beam deflection equation is for simply supported left hand and right hand side with a distributed load. This is used in the case where you don't have any datums supporting in the middle of the beam. And this check has to be done just to make sure that your beam actually needs some datums in the middle. The second equation is fixed on one side and simply supported on the other. What this does is takes the end of our beam and then takes us to the first datum target. And then equation 3 is for fixed left hand and right hand, and this will be used for the intermediate sections with distributed loading. The assumptions I've had to make to use these beam equations are that fixed boundary conditions on intermediate sections better mimic canceling moments from the distributed weight from one section to another. So the sum of the moments around an intermediate datum labeled Fx are assumed to be 0 because the distributed weights kind of cancel out each other, and then the ends of our beam are going to be simply supported. The basics of my code are that you enter the constants like length or modulus elasticity, and then I set up distributed weight and moment of inertia vectors. Then I send it through a for loop that increases the number of sections for each iteration, and each time it goes through this loop, the deflections will be taken on each of the sections, and the exit criteria for the loop is that it is either less than 3/1000ths of an inch deflection or until the maximum number of sections has been reached. I've currently written the code and the output looks correct. However, I still need to validate outputs with known beams and test the code for robustness of inputs.